Okay, so welcome to IterateUX. The people who all are new to IterateUX, for them it is welcome. And people who all are in the community from long time, so welcome back again to our IterateUX event. So let me just go ahead. Okay, so today's our session is for intro to data experience with Taylor, and he is a product designer at Splunk, and he is one of the amazing mentor in our community. So thank you so much, Taylor, for having this session. We look forward to this.
Thanks for having
Oh,
me.
yeah. Okay, so moving ahead, I'll quickly introduce about IterateUX community, the people who all are new to this community. So we are a community wherein we have UXers from all the levels of experience, different backgrounds, wherein we provide a platform wherein people can learn, connect, and grow with each other. So we are IterateUXers, UX designer for all UX designers. So that's the thing that we have. We do arrange weekly events as our today's event. So you will get to learn many things from our weekly events as well. Then we do arrange design challenges as well, as our upcoming design challenge is there from 15th of August, which is there for 4 weeks. Feel free to utilize that for working on any projects. I will give you a quick intro about that as well later on. Then we do arrange monthly whiteboard challenges as well to get practice on your interview skills. Then we do have portfolio and resume review ticketing system on our Discord platform. So feel free to use that to get some help from our mentors, like our amazing mentors. Then we do have some design feedbacks and other feedbacks channels on our Discord platform. So feel free to join our Discord channel as well. Kim will be sharing the Discord link in our chat, so feel free to use that. Then these are our next upcoming events. So our next event is on talent is not enough. Real world advice to survive in the world to professional UX. So this talk is there from Patrick Hook, and he's a user experience leader at Google. So our next Thursday event is with Patrick. So feel free to join that event as well. Also, as I mentioned, we have upcoming UX challenge, which is from August 15 to September 15. For 4 entire weeks, you will get some team to work on some good problem statement, wherein you will be working on entire design thinking process. You will get mentors as well and your team as well to work on. You will get a good case study at the end of this particular challenge, which will help you to get a job or maybe showcase that in your portfolio. So feel free to join that. We have registration link as well. Kim will be sharing that link also with you in the chat. So feel free to join, register out there. Okay, then moving ahead. So before we begin, please unmute yourself when you need to share something. Okay, so that is one thing. Make sure of the chat, we will be checking your question. Okay, so we will have a Q&A session at the end of the session. Feel free to ask question in our chat box. So we will be taking that for a Q&A session at the end of the session. Thursday event, as I mentioned that, then engage in our Discord with different channels and start conversation. Be kind, have fun. Okay. Okay. There is one more thing. If you really like our sessions, if you get some more learning from our sessions, more experience, feel free to donate $1, which will help our community to get some fundings within a community to survive all the platforms, tools, and all those areas. Since we are a non-profit organization, we have everything, all the events for free. So feel free to donate the community. Okay. Okay, let's get the event started. Also, Kim will be sharing networking sheet in the chat. So feel free to fill out that as well, just to connect with each other. We will be sharing volunteering and mentoring sheet as well if you would love to register for that. Also, one more thing, if you really like the session, if you get some nice learnings and those kind of stuff, feel free to tag us, feel free to tag Taylor on different social media platforms with your learnings and other areas. Okay, so I'll stop sharing and I will hand over it to Taylor. Please go ahead.
Yeah, thank you. So it's so nice to see everyone here today. You said like okay, and then I used like Google in the same sentence, and my device went off behind me and was like yelling at me. So well, I hope the rest of my presentation that's not going to happen, but we'll see. So it's it has a tendency to do that randomly sometimes, but
Uh,
appreciate.
um, sorry to interrupt. I would like to take one photo before we start. Is that okay with you?
Sure.
Uh-huh. Sorry, I just missed that. Okay, so let me take a photo. Cheers.
Mhm.
Okay, I've taken a photo. Great. Please go ahead. Mhm.
Awesome. Okay. We didn't get Google Assistant in the photo, but it's in the background.
Yeah.
All right, let's get started. So I'm going to go ahead and share my screen. So yeah, thanks everyone for coming today. And I've been in part of IterateUX for about a year now, doing different mentorship sessions. I do portfolio reviews. And today I wanted to talk through some of my work and really what I do inside of Splunk as a part of data experience. And we'll discuss a little bit about what data experience means and some of the design principles for data analytics. So I think everyone obligatory, you can see my screen right now. Okay, great. So, all right, I'll get started. First thing I want to do is just introduce a little bit about me, so you get to know me and what I do. So in 2 minutes or less, 3, 2, 1, go. Some personal things about me that I love to do. I love to travel. My girlfriend's from Peru, so I actually spend a lot of time there. I have a deep fascination with video games, particularly people like speedrunners who can break apart and understand the design of games. The design of fun is always really interesting to me. I've played guitar for about 10 years, on and off. I love metal music. This is me on a dinner date with Pasheen the cat. I was a referee for about 10 years, and I was so done with people by the end of it. I was kind of like this. And then that's my dog, Miko, who growls at me every time I come down the stairs, but I know he does it out of the love out of his itty bitty heart. I make fun stuff. I originally started as kind of a developer, developing different kinds of really interesting and unique data applications. So I was fascinated with Twitter and this idea of being able to fly around a virtual city and viewed where people were tweeting at different times. I applied that to VR, where you could fly around Indianapolis and see where people were tweeting around the Indianapolis 500. And I just love doing these experiments with programming and data to try like these really interesting, unique ways of visualizing information and interaction between a variety of different visualizations, as well as then applying that and trying it with, say, design principles with the ones on the right, trying out different new ways and new approaches of designing. I make serious stuff. So professionally, what I do is I take very, very, very complicated data that could have petabytes of information coming in a day. And we try to make all that complicated data in an easier to read format that is digestible for our customers. When you hear the name Splunk, what Splunk does is we call ourselves that data to everything platform. So anything from your security information to your information technology. I am in right now DevOps, which is your development lifecycle of creating applications and monitoring those applications. Anything from phone applications that generate data to your networking that creates data, and much more that we'll get into here in a bit. We take something that looks like this and we turn it into these beautiful visualizations that you can make business decisions around as a part of your organization. The way I like to think about it is if you had a blacksmith and they were taking the metal and molding it into something that was actually useful and usable to people as a variety of different toolkits, we do the same thing in design for data, where we have a very broad spectrum of data that comes in, and we shape and mold it to whatever the customer problems are that we're trying to solve for. Getting into the actual talk today, what I'll go through, and I may skip through some of this depending on our time and to allow questions, but the first one is, what is actually data experience? What does data experience encompass? Why should you care about it as a designer today versus, why would you want to specialize in it if you were interested in product design in particular? The next one is data experience principles. So the actual principles that I use day to day in my work to make data more usable. And then the final one, which we'll see if we have enough time to get around to it, but it's called adaptive complex systems, which is the idea of taking data that could always be changing or being moved around and trying to make sense of it for your users. Think of something like a stock market or something like that. It's always having new data feed into it. It could always be moved or modified in some way that changes the dynamics of what you want to see, that kind of stuff. First question let's answer is, well, what is data experience anyway? And what I would say is data experience is this idea of humanizing the way that we look at data today. A lot of people, when you think of data, you kind of think of, those Excel spreadsheets, simple line charts. And, maybe you threw one of those together in high school or something like that to kind of present these very simple diagrams of something that you wanted to show. Data encompasses so much more than that. When you look at data, this is an example where I worked is one instance in the American Academy of Pediatrics. And one of the things they were really interested in understanding was that in developing countries, there was this black box of data around neonatal asphyxiation, which means when a baby is born, sometimes they can't actually breathe. And the way that you treat someone treat a baby who is experiencing neonatal asphyxiation, and the rate of death is much higher in those developing countries than in the developed world. And by understanding the data on why that's happening, by going out, interviewing and understanding people, by data collecting in a way that makes sense, you could drop a 23% infant mortality around, neonatal asphyxiation down to 0.1%. And so you give the right toolkits for the developing world, as well as train the doctors who are going to those countries in the things they need to teach that are most important to them. It can be used in, as an example, when I worked at Rolls-Royce. Rolls-Royce, what they did in GE Aviation is they have all these sensors that are a part of their aircraft engines. And with all these different sensors and everything that are going on, you could use those sensors and all this very messy data that they collect to train people and help them when they're actually diagnosing and repairing a faulty aircraft engine. And what I mean by training too is they could also take it and maybe apply that data into their virtual reality for training. For GE Aviation, they used Google. Why am I blanking on the name of it all of a sudden? But the Google glasses. I'm wearing glasses right now. My God, Google glasses, which will help and show the data on, say, if I'm applying enough torque to fix a bolt on the aircraft engine. And as a result, they saw a 70% reduction in aircraft engine, the aircraft engine coming back because of an error during the repair process. At Splunk in particular, we use things like McLaren. McLaren uses us, and what they use us for is, I believe when McLaren was at my organization, they said even just one qualifying lap, they generate about a terabyte of data. And from that terabyte of data, they're able to really dive in and understand what's happening with the vehicle to eke out that 0.1 seconds that will win them the championship. Everything from your tire PSI levels to your brake temperatures to your speed, all of that is captured, and we try to make sense of it in a way that will help people make decisions around their vehicle and eking out the performance they need to be victorious. So we've done lots of different kind of visualizations and design around this. The other component, again, when we're thinking about humanizing data, it can be even to the point of being a life or death kind of decision. An example of that happened, I think it was in the 80s, was the Columbia Space Shuttle disaster. And one of the things that was mentioned before the actual launch that was a major concern for the engineers was something called the O-rings failure rate on the aircraft engine, or sorry, not the aircraft, the space shuttle. And the O-ring is meant to separate each of the individual fuselages of the areas of the fuel before it's ignited and provides the thrust to get it to the atmosphere. Get out of the atmosphere. And so one of the concerns was, well, this is the temperature that we're launching at on the launch day is so far out from anything that we had before. And the concern was there would be potentially a failure like there was that could have resulted in the death of the 7 people on board, which there was. The way the engineers presented that data was something that looks like the visualization here on the right. And the way that you're supposed to read this visualization, guarantee many of you can't read it, I couldn't read it, is the top here shows the temperature of the day. And the way you're supposed to read this is the failure rate here is attached to these individual squiggly lines that you kind of see here. That's supposed to represent a failure of the rocket. And so if you're looking at the overall trend, it's really hard to understand what's actually going on here and like the relationship between this temperature value that you see here and the relationship to the failure of each of these individual pieces. If they clean that data up, this was a variation of that was shown after the fact. It looks more something like this. So what you see here is this is the number of failures by the temperature. As you get into 65 degrees, you see occasionally you still have like a couple of small failures, but there's a slight trend that you're starting to see kind of take form here of the number of failures. And when you start looking at, let's look at this in the longer context of how far this is outside the normal, not normal distribution, but I guess the distribution of temperatures. This launch day was at 30 degrees. And it was so far out beyond anything that they had tested before. And so when I believe it's like when the government did an independent audit of this in the future, and they looked at the data, from that data, they said that the O-ring failure rate was around 16% likelihood of failure rate versus NASA's expected failure rate of 0.01%. And so by visualizing this data, what you can see is when you're communicating this, say they were communicating this to their manager, you can communicate it more effectively so people can make better decisions about what is going on in their organization. And so, regardless of our technology suite, we're taught as product designers to make sense of data in a way that can help people understand what's happening in the real world. And, we can break apart the kind of problems that they're actually trying to solve for. Okay, so that's the basics of data experience, humanizing data. Let's go and start looking at the data principles that we actually use to solve some of those problems with some real world examples. So when you go and if you ever talk to a lot of times when I talk to organizations, one of the first things they talk about with data is they have these very vague terms that they try to use to fix something. It's the same like if you're building a product in the normal, say, product space, people will tend to like overestimate like what they're solving for. As an example, like maybe you're building, I'm trying to think of a good example off the top of my head, but like maybe a dating app or something like that. And it's like, I want to build a dating app that's very efficient for people to use. Well, that's very vague, and you're not really getting anything out of that problem statement to actually solve for something. It's the same way with dashboards and with data in general, is they'll say, well, we have all this data and I want to show all that data that we can to improve efficiency, show all this trend of everything that's happening and solve system problems. Well, when you're that vague, when you actually apply it, you kind of, and this is an exaggeration version of this, but this is kind of what you end up with. Where you're trying to solve everything at once. So what you see here, this is the London City dashboard, the government website. Government websites always make the best websites. And what you see here is it's trying to use wind speed. You have Twitter trends for London with the individual hashtags. You have traffic cameras, BBC London News, and none of it is telling a cohesive vision of what we're trying to solve for. As a result, you end up having conflicting pieces too of information. So as an example, red is often used as a color to denote, like, say, an error state or something that's going wrong, or something in excess. But when you read this, as an example, wind temperature is red here, but the red is used here that says the central tube line status is in good service. So the red here is not in error state. Same way down here, when we look at electricity, we see demand at 48,211 megawatts, and it's red. Does that mean that it's far above average in the way what it's trying to tell me? Does it mean that this, like, is it being used as red like this because it's like just trying to denote the like a color to draw my eye to it? Is it being red because it's different from a day ago? Is it different from a week ago, a year ago? You can't tell from the information that's here of what's actually going on. And so what you want to do is you want to keep everything very specific, in the same way that, we as designers build problem statements. We want to do the same thing when we're building our design with data. So in my particular world, where I deal with things like system reliability engineering, it's focused questions. Like, as a system reliability engineer, there's 3 values I want. I want to identify severity of an outage. Who needs to be involved? What services are affected? And from those 3, I want to provide and build a dashboard around those 3 things that are actually providing value to the customer, rather than just trying to put as much data on a screen as I possibly can. If you're familiar with things like Nielsen-Norman heuristics that talk about things like link between system and the real world, we apply the same kind of things with data in the real world. So if we have something that you see here where we have a rack of servers and you're wanting to see, which server is actually having a problem, you could identify and say, well, the site reliability engineer is going to be seated outside of this server room. And if they go in the server room, we want to link and have it in the same orientation as it was actually built in the real world. So when you actually go into the server room, they immediately know that they're going to C5 to figure out, or C4, that those are the places I need to go to actually start resolving whatever problem, exists in the system. It also lets me know, like, if I'm facing the right way in the real world, if the air conditioning, in this case, the HVAC, the cooling system is working, what's on and what's not on, and then the overall metrics as single value charts up here that tell me some information around what's happening. This is more of an operational dashboard. One that would be more like a business dashboard that you're using for business metrics might look something like this. So what this is mainly meant for is, going outside of the individual person that may be trying to resolve to see the system. I want to look across how everything is doing in my system. So you can see here we have things like our production cost and our energy usage, operational risk, the amount of models that were actually produced today, your overall equipment effectiveness, and then again, linking between system and the real world, you can see here, if there is something that I want to kind of look at with efficiency here, or, with the shifts, it's attached to what it looks like down on the shop floor. So again, we're just trying to attach everything that we're seeing in our system with the real world. And if we're doing business metrics, those might be different problems and different visualizations we need to solve with than if we were doing it with more of that operational piece that you saw in the previous diagram here. Second one, data principle, is eliminating and prioritizing complexity of your data. And so a lot of beginner people, when they build these dashboards, they try to put everything on the dashboard at once, and they put so much information versus, say, scaffolding that information. So if you think about a horizontal, everything's on the same page versus scaffolding it vertically would be maybe a visualization tells me a bit of information that I need. I click on it, and then it dives me deeper into the context of that data point. You could think of a overall metric of server health. And then if I clicked on the server, it would tell me CPU utilization and RAM or something like that, versus everything being on one page altogether. Another exaggeration of that would look something like this. This is like the worst example of if you were trying to visualize information here. This is actually student data here for individual people. So if I look here, I have Frederick. It tells me their overall grade. I believe this X is like the last grade that they potentially had. They have a single value here for year to date. Their last versus their new, a spread of information. I don't even know how to read that. And then the weight numbers. And then my favorite one is the attendance chart, which I believe the gray ones here are missed attendance and the pink ones are actually attended. But if I asked a teacher, what are the key things that you really care about? The way that they would probably verbalize this is, this doesn't really tell me anything about, like, at a glance, what's happening here, right? I have to count. I have to go to this individual section and go 1, 2, 3, 4, 5, 6, 7. There's a chance of miscounting too. 1, 2, 3, 4, 5, 6, 7, 8. And then I have to draw that conclusion from that evaluation that I'm doing, single person by single person. And then you have at the bottom an aggregation of everything that's happening. But if the point of this is in the same way we strive and we talk about how, in web and in mobile, your attention span of a user may be 5 to 10 seconds, right? To grab their attention and get them to where they need to go. It's the same thing here. They haven't evaluated what the teacher may have wanted to know. And because they didn't, they put all the information on the page in one location, and they don't define what is the most important thing that the teacher needs to know about these individual students or the aggregation of these students together. I took a crack at this, like, just as a example of myself, like, playing around with it. But, I would have framed this and, in the real world as a product designer, I would go out and I would understand and ask them questions like, what are the most important things for you to see as a teacher? And you may get, oh, I want to see an aggregation of individual users. And if there are outliers in that, so like, say, student A and student B are performing much worse than student C and student D or the rest of the class, I want them to kind of be brought to the forefront to know that I need to have more attention to those individual students to assist them, or to talk to them. And so you would talk to the people that you need, And then you would build some kind of visualizations that go through that. So I may want those individual users here, a general trend of the data that they might do, but then I'd have single values at the top to let me know how my overall class is performing, as well as if there were referrals and detentions, how many referrals and detentions I've had in my class over the entire class period. And then at the bottom here, this is actually the third kind of piece is analytics facilitating your action. So when you look at the bottom here, when you say 4 students did not attend lecture 2, this could be something that points out at the bottom some key insights that are like 2 levels deeper in the data that we want to grab the user's attention, that they might want to look at, and then facilitate action through that. So I can click on this individual chart, or I can see that individual data, and then I can click on the individual assignment to take me to that assignment rather than just give them the metric. A lot of data dashboards, what they do is they just give you the data, but they don't give you actionability around the data. So you want to provide action and context around the data that you're seeing, so you can have a better, you can get people into the context of solving the problem faster than just understanding the problem as well. Examples of that more at the interaction level, maybe something like this. Actually, it's not playing the, let's see if I can get it to play the video. I know it's playing. It's not actually playing. Let me load this again. One second. Come on, you can do it. Let's see if this grabs in. If it doesn't play, I can just describe what happens in the video, but there we go. So at the interaction level of what I've just described, you can see where if I hover over an individual action, it kind of highlights it to me in the context. If I go down here and I'm wanting to see altitude over time per plane type, by clicking on the aggregation here of the average, I can then see the min, max, etc. from that line chart. So just showing that again, I click on it, and then it breaks that data out into more data that's contextual to what I'm wanting to know. Same thing with pie charts and things like that, where by hovering over it, I get the percentage value here along with the actual full count of what's happening. Okay, where are we at? We're in one. Okay. And then let's choose the right visualization for the right problem. It's number 4. So this is more hierarchical, but I'll just kind of describe what each visualization is really good for. I love single value because you can scale it up to whatever size you want it to be. It can be very small or very large. I like for filter gauges, what filter gauges are good for is, say you have a CPU and at the middle, it's supposed to be at 50%. And if it falls below 50%, it's being underutilized, versus if it's 100%, it's overutilized. So you can use these marker gauges to determine a variation from the mean that you're trying to judge from. Compositions. So when we talk about pie or donuts or tree maps, heat maps are another example of this. They're not really good at like very specifics of what's going on. Pie graphs are often overutilized, but what a pie graph is really good at is if I want to see a composition at a glance. So like, how many students, going back to that student example, how many students are failing the class right now or passing the class? At a glance, within 2 seconds, I can understand that 85 or 90% just are passing versus 10% are not passing. It gives me like a little bit of context of what's happening across the entire thing. Composition over time, stacked area and stacked column charts. Complex system status, we talk about something maybe like a US map or a what I showed you earlier with those examples of a visual of the system reliability engineer floor map where you could see each of the individual servers. A lot of those end up kind of being the center point of the visualization and then, or sorry, the dashboard. And then by clicking on it, you could provide more data or other visualizations that overlap the primary SVG visualization. And then showing trends over time is things like line chart, area chart, and column chart. Line charts are overutilized, but again, they can be good in the example like I mentioned where you can click on it and it breaks the data out for you in a little more context, or you can kind of highlight across it or scrub across it to see shorter time ranges. Which time are we at? 13. I'm going to skip over this one and just kind of go into another couple examples. So a real world example of choosing the right visualization for the right problem. This is a problem that I've dealt with in mobile. This is an actual problem in Splunk that was solved by me. So in our observability application for web, we have something that looks like this for our heat maps in our web application. So the idea is you can take the visualization of the heat map and scale it to whatever you want the heat map to be. It actually looks a little bit better when it's smaller because you can understand the trend a little bit faster of what's happening. Again, at a glance, you could say maybe, I don't know if I'm looking at this, maybe 90% are healthy versus 10% are unhealthy. And the idea is then I can take my cursor, I can hover over each of those individual little green squares or red squares, and it would provide me more data around the square, the information. So this is network out by server. So it could be the rest of the server information around a node. When you apply that to mobile, you end up with something like this. So in mobile, you want it to be about 44 pixels by 44 pixels to accommodate basically the amount your thumb can tap. Well, if you apply that to the same way that we want to do it, which is these squares, what you end up having is you can only show 8 squares before it pretty much takes up the entire space of your visualization. And if you have hundreds of these, this isn't useful at all. I guess you could expand it. You could click on that little expand icon and have it take up the screen, but you'd still have to scroll through all of it and you would lose the context of what the heat map is meant for, which is in 5 seconds or less, what do I need to put my attention towards? And so this is the wrong visualization to fix it for mobile. In web, it's the right visualization. So what we ended up doing is we ended up breaking this out in terms of almost like this horizontal bar that shows that same information and breaks it apart, like say the red, the yellow, and the green, to give that same context of what percent are in error state or like over 800 milliseconds versus the ones I need that are healthy in the under 250 millisecond range. A couple other ideas that kind of came from this is if the red here, it is better to be slightly inaccurate with the data visualization to accommodate maybe an action from the user. So for instance, if there was only one over 800 milliseconds, but that one is really important, and you wanted to click on it in your thumb, if it was realistic the way it would look, it would be so razor thin, it would look like a pin that you had to click on, and you couldn't click on it. So it's better to expand that and be slightly inaccurate with the data to a point where now it's tappable, like this little red area is enough to be tappable by the user, but it's fine because we still give kind of the value of the data underneath of it to explain what's happening. You could also, we did this another way where these are tappable as well. So you can click on these individual datas and that shortcuts you like 2 levels deeper to the error state, or you can just click on the one at the top that just takes you and gives you like an aggregation of the data. So there's all these like little shortcuts and little things that you had to consider to choose the right visualization for the right problem. Let's see here. I'm at 9:17, so I'm going to stop here and let people ask questions. And if we have time, I can go over the last section.
Yeah, sure. But this was pretty like informative actually for all the designers. Like nowadays, like we have many areas where we need to showcase all the data, like from starting from scratch, like when people work on the research and all those area, showcasing those results also in data visualization, which will help maybe hiring managers to see the data also. So that is also one thing that we usually use, and these are like real world experiences like you are presenting. This is amazing, actually. Great. Anyone has any question, feel free to unmute yourself and yeah, or maybe text it out here. Mhm. Yeah.
I'm not like Google Assistant. I'm not going to yell at you. Don't worry.
Uh-huh.
We have a question from Carmen. Would you like me to read it out?
Sure.
Mhm.
Sure. Okay. So, oh, sorry, it's just scrolled here. So it says, thank you. Love your explanation and examples of visualizations. With the interactive hover example, how would you imagine an individual using assistive technology being able to explore that dashboard?
The interactive hover example. You mean like the one that was on something like this, where you would hover over something to get data? I want to make sure I'm understanding. Interactive hover example.
Carmen, is this the slide that you were referring to? Oh, with the video that you were trying to get to play earlier.
Oh, this. Oh, you meant the okay, 1 second. This one?
Yep.
Yeah, so there's a couple of different ways for accessibility wise this can still work. As an example, if you're focusing this area here, the accessibility of a keyboard, like tabbing into each of these individual pieces, like as an example, laptop, a tab on laptop could highlight the laptop section here, and another tab could go to the individual piece here. And then by clicking return, it would basically expand it to whatever content you would want it to be. Accessibility wise, we have a couple of things where we still, like on the Splunk side of things, we need to do a little bit better, in my opinion. We don't really have a design system that's well dedicated towards accessibility. We've been trying for data, but that's like one way you can apply it. So it's not just the hover example.
Philo, can I ask a question? Good evening.
Sure, go ahead.
So thank you for your presentation. So my question would be, so would this just be more the way you see data, the way you want to present data, or the way you know how to use the tools that help you visualize, or the way you understand data? Which one is more emphasis on, or do they all have to come together? Because yeah, what
You
can the
said-
tool do? How do you see that you can present data? Or yeah, that's it's really complicated for me right now.
Yeah, there's a great graphic I have later in the presentation that I talk about this. There's a variety. I'll explain this here, but the way that I think about data is you have kind of these different areas that you want data to be represented, and it isn't just linear to say we want everything to be like at this wisdom section of like hey, I've built a presentation out. I've kind of scaled it to some visualization. Sometimes, like I said, like the American Academy of Pediatrics example, it was just like, what data do we have, right? The problem is, what data do I have? How do we understand the collection of that data? And then from the making sense of that collection, get a vague idea of the information we need to better inform and help the doctors get what they need. You could have something that is a little more contextual, like data, I would say, or sorry, Splunk, I would say. We do deal with like very messy data, but it's like, how do I start connecting the pieces from all this dissonant data to what happens? How do I pick and report based around two insights, maybe from, server over here is experiencing issue, and then I have network out over here has something that's telling me something. How do I take those two very dissonant different things and then join them into something that is actually useful and usable for decision making? The one that's conspiracy theory is an example. Say you're investing in cryptocurrency or something. It's not, crypto isn't bad in and of itself, but like as an example, you always have confirmation bias over the thing you're looking for. Facebook gets in a lot of trouble with that. They use algorithms to understand, the data and information of people, how people look through things. But because it's people always kind of search for things that confirm their own biases. So if you're building an algorithm's only as good as the bias of the user that's presented to it. So if the user is always looking up, say, I believe, 20% of, I believe Democrats are wrong in X and Y areas, or I would believe Republicans are wrong in X and Y areas, that's just going to confirm, and it's going to, the system will pick up on that, and it'll only present the similar forms of information to the user, right? That's a different problem altogether, but we always, I think one thing, this is going off a bit on a tangent on what you said, but one of the problems is we often use AI as this catch-all solution that is going to solve everything for us possible. But the reason I got into data experience and data UX is you can't build everything from AI. It always comes back to the user. The user is the one who's performing the inputs. Inputs control your algorithm and what's happening. And if you're not intelligent about the way you're doing that and you're not cognizant of it, you could have people looking in the wrong areas to solve the problem. And so everything comes back to the user. The things that I mentioned about interaction design and stuff like that, those are toolkits that help facilitate people understanding what they're seeing. But there's that underlying need of understanding the user always underneath of it that requires our research and product experience.
Yeah. And also, I would like to add one more thing out here when we say data visualization, which always helps to tell a story. It is not only about the graphs and what kind of a graphs we choose, but it always helps us to tell the story about the area what we are trying to explain, and it highlights the area what we would like to showcase. So that is a very important point for the data visualization.
Yeah, thanks for your
Yeah.
question, Benjamin. There's another question here that says, how do you push back to stakeholders who are used to seeing every piece of data?
Well, yeah, the way that I typically try to do it is, if you're looking for value, right? At the end of the day, people want value in what they're, presenting, right? If you show everything and, I have a user research study or whatever it might be that says, here are the 5 main things we want, right? I try to break it out first as saying, what is it that you're wanting to show, as far as information to the user? One, does that information match with the expectation of what the user thinks they want. So I may, go and do user interviews and talk with people, make sure their needs align with whatever the stakeholders are doing. And then once you have matched that, if a visualization, like that idea of like everything's on the page, at the end of the day, what I say is, well, how is this particular visualization doing something different than the visualization over here to solve that problem? Is it the same problem we're talking about here? And I may present, two variations, an A/B version of it. One may be the one that I think is like way too overbloated with information. And typically when I show that to the user and what they're trying to accomplish, they'll side with the version that has enough information to get what they need. And if there's pieces that they say are still missing, my argument is to build that into a separate dashboard or a separate value stream that they can use versus putting it into the same value.
That comparison aspect sounds like a great approach to emphasize the difference between the two. Okay, so what are your interests? What interests you most in regards of data visualizations, and what attracted you into this field?
Yeah, so I started out as a developer, and when I went into my master's program, I was always interested in. I always thought data was like just line charts and bar charts, right? I didn't have a lot of interest in data and analysis, but I learned slowly through time that it was much more akin, like if you've ever seen Minority Report or Iron Man, where they're cool, like moving these cool interfaces around and seeing all this cool like visualizations. A lot of the best data experience kind of solves problems in similar ways to that, or are very interested in very complicated problems. I chose data experience because it's not like any other part of UX, I feel. And what I mean by that is UX always changes, even with I'd say like normal user experience kind of work, but they're very dissonant, different problems in the data space to solve. If you're pulling in petabytes of information and, I have to deal with 6 or so different personas of different people that might be using this to build a toolkit. Like, again, we just provide kind of a toolkit, and it's from the toolkit, it's up to the user to kind of build the best practice. And so us as designers, we kind of have to reverse that script and try to figure out, yes, they can build it like however they want, but how do we be prescriptive enough to have them make their own decisions, but make it good visualizations that they end up building rather than building it in the wrong context. So a lot of the interaction components of it, a lot of the documentation, in product documentation, and thinking about how that connects the dots, having real product examples that push the user to think about it a particular way are really interesting to me. My start to it was I had done I worked for a professor in data who was just a data into data analytics and data science. And his thing was doing like natural language with data. So I wrote papers for research for taking natural language and applying it to data problems where you would speak to a computer and it would, to that point, like validate basically if your hypothesis was correct or incorrect, and then spit out like a visualization that told you, you thought, that in Kenya, the rate of HIV infection was 10%, but it's actually 4%. Here's the differential in the data from what you think versus what the real world, user thinks, or the real world data says.
Hey everyone, on behalf of IterateUX, we would like to thank you so much for watching this week's event. If you like the content, please leave a like and subscribe. We'll have events every Thursday at 5:30 Pacific Time. Join our Discord in the description to find out more.